You are using my book. If you are in frame, skip like 2 papers, 4 pages. If you are doing this same, don't skip any page. Okay, let's begin. You write small changes. Let's hope you had that communication.
Teacher.
Eh?
Sure.
So you write if theta is in radians.
So we can see what
You can. I don't want to complain. Just keep quiet.
The camera is what?
So far, we can't see what's on the board.
Okay, what you're writing is small, so should I extend it in front?
Yes.
But your
Yes.
handwriting.
Just push it. Send it this side. You have to say it.
Okay, let us try to extend
You buy good phones.
Nothing. What you mean?
This guy bought an iPhone.
Low.
Low.
Here comes.
What I'm happy.
What about there?
That's good.
That's better.
No. Just that.
Okay, now, hope you can see. Hope you can see.
How can
Then sine of this angle.
some of your things today?
To 1. What?
naye abaana abamu bano abajja mu breakout room tebawandika ku submit.
Hope you are seeing good now.
Yes,
Yes.
teacher.
Okay, fine. So, you're doing a small changes. If our angle is measured in radians, if you have a calc, try to put your calc in radian. Get your calculators. I want to show you where this one comes from, what I've written here. If theta is in radians, okay, meaning in radians is a very, very small angle. Okay, okay, actually I want to do that. Now try to put your calc in radian. Now, Sine of a very small angle, sine of this angle 0.0002. This will tell the same angle. We tend to 0. You put your calc in radian, try to verify this. If you have a very, very small angle, you put your calculators. The sine of this angle will tell the same angle. If you have the tan, again, the tan of a small angle, make this 0.01, you get the same angle. But for a cosine of a small angle, to give you 1. You put your calculators in radian. Go to modes. You have to put your calculator in radian. Go to modes and right so hard. And try to put the calculator in radian. Then I will verify this.
Teacher, mine is different. Teacher, mine is giving me 1.999.
When you round
Me
off,
Yes, teacher, same thing here.
when you round off the SO number,
Singundi standard form.
exactly. Then you put a cosine very small angle like this one. Aren't you getting 1?
Yes, teacher, I'm getting.
Eh? You're getting 1. Eh?
Yes.
Now, if the angle is measured in radians, meaning it's a very small angle, sine of this angle, you get the same angle. Even the tangent of the angle, you get the same angle, but for a cosine, it will give you 1. Okay?
Okay.
And when you come back here, you should put your calc in radian. Sine of this angle, you get the same angle. Tan of the angle, you get that, and cosine, you get 1 to give you 1. But basically, I need to know that. It's very, very important. This is where we have begun from. Okay? Then, shall we look at other limits? Other limits. Just as changing x tends to 0. Okay, what happens here again? The sine of this angle changing x. You give the same angle. The tangents, you get the same angle. But for a cosine, it gives you 1. You write that as well. We have other limits and say as change x tends to 0 here. The sine of the angle will give you that. Again, this is very important for you to know. Okay?
Yes,
Okay.
teacher.
Yes,
teacher.
Good girls. That's why you are my best. Now,
No.
and don't forget you have a paper on reporting the following day. And this work will be there. Are your parents around? Are they attending too?
Yes.
no.
Yes.
Yes.
Attending.
If your dad is around, your mom just call her him to come and enjoy it. Now, this is what we have. But from here again, I want to show you this. Let me remove this part here. From this part here again, again shall say, changing x 0. I have sine of this angle x plus change in x. This will give you sine of the angle. You get x. The tan of x plus change in x will give you tan of x. And the cos of x plus the change in x this will give you cos of x. If you have any question you can ask. This is what we have. This delta x tends to 0. Sine of x, man, this is turning to 0. This part again, this whole part is becoming a 0 here. That's why you shall get sine of x. Now this will be out. When this will be out, then this will be out. That's how we are getting the sine, tan, and the cos. Okay?
Okay.
Remember, we began from this side here. Here, you understood. Now we are in this part here. Now, the introduction part is done. We are going to do the real work. We are going to do the real work. We are going to combine this part here and this part here. Again, you recall how we differentiated, how we began this topic of differentiating logical work, differentiating from first principles. Do you remember?
Yes. Yes, teacher.
Good. Now, we are here. So you write our topic for today, differentiating trig functions. This is our topic for today. Differentiating trig functions. Write a very big heading. Differentiating trig functions. Trigonometric functions, okay, trig. Differentiating trigonometric functions. Differentiate trig functions, then you write trig functions can only be differentiated if the angles are in radians. You write that trig functions can only be differentiated the angles. Wait, did you want? Trig functions can only be differentiated the angles are in radians. Trig functions can only be differentiated if the angles are in what? Radians, okay?
Yes.
Hey, you are now 112. Where are the rest? Now, you girls, listen very well. The work we are doing today, I don't want to cram, I want you to understand. That's why I've given the first part here for you to get to know it. We are going to combine, we hope you know factor formulas, right?
Yes, right.
We do.
You write all the four factor. What's the first factor formula? You gave it to me. I want you to tell me. What's the first factor formula?
And of course, science.
Pardon?
Addition, of course, science.
The factor formulas are the first one. This is not part of the work, but you just write somewhere. Okay, you say recall. I recall if I sign of X plus sign of A, let me call it A. Sign A plus sign B. This is given by what? What do we get here?
2.
2,
2 sin A plus B.
Plus B out of 2, right?
Out of 2. Cos A minus B out of 2.
A minus B out of 2. Okay, that's correct. It's 1, 2. Just sign A minus sign B. What do we get here?
You get cos 2 cos cos A plus B
A plus B
out of 2 sin
okay.
sin
A minus B
out of 2.
out of 2. Okay. The third one, you have cos of A, you add cos of B. What do we get here?
You get 2 cos A plus B out of 2.
2 cos A plus B out of 2. Then
Cos
A minus B out of 2, right?
A minus B out of 2.
Okay.
Yes.
You have cos of A minus cos of B. What do we get here?
Minus
Negative 2 sin
Okay. A plus B out of 2.
A minus B
Let's sign again A.
sin minus B out of 2.
Okay. Who does it know? Said recall. Those are factor formulas. That's the calculus work, which he taught you very well. When you came to A level, I think we talked. I briefed what A level is, what A level requires. Never postpone issues. If you have any problem, make sure you find a solution immediately. I did this work, and A level, what we do, keep on building on what we have done. Now we are going to use the factor formulas to differentiate what I'm going to cover today. So now, I beg you, make sure you know all the 4 factor formulas. You don't need to have a logbook. They should be in your head. May don't ask for a lot. They should be in your head. Now, let's go to our first question. Question number 1. I'll do the first number, okay? You do the second number. Have you heard? I'll do the third question, you do the fourth question, right? Why are you quiet now?
Yes, teacher.
Yes, teacher.
Good. I've told you we are going to apply the factor formulas, right? To differentiate. There, our first question is here. Make sure you're very attentive. If people are taking tea, you wait. Differentiate. Get the following fixed functions from first principles. Part A, sine of x. Part B, cos of x. Part C, tan. Part D, sec. Part E, sec x. Then part F, cot. This is what we are going to do for today. We are going to differentiate those from first principles. Sine, cos, tan, sec, cosec, and cot. Correct? Fine. After Edward, the move of swing, but that's why it was already night. Edward. Oh, that really I'm a day. Think I'm taking that. Huh? Edward. Thank you. Now we're doing all this. So I'm doing part A, I'm doing part B, right?
Yes, teacher.
I'm doing A, you do B. Then I'll do F, you come and do C. Then I'll do D, then you fully work out it. That's be the order. Okay, let's begin. So we have part A, y is sine x. So this is how we begin. You let your y be this function, what this side of x. That's how we begin, okay? Now we are looking at small changes. We are going to add small increments in y, you will add increment in x, okay? The small increments. Now we shall say y plus delta y changing in y equal by sine of x, add a delta in x. Like that. We add it on x and it should be in brackets. Now come and make change in y the subject. Our change in y given by sine of x, you add a delta in x minus now your y. Up here we are together. Now, but you know the value of y, meaning our change in y becomes sine of x, you add the delta in x minus y, but what's your y? Y is here, sine. Now we are this part. Once we reach this part here, you are going to apply factor formula on your right hand side. Okay? You come and apply factor formula, which you have just written up there. Now change in y becomes, this will be now a 2, okay? 2 cos. You first add them, you add the x, divide by 2 against 9. Then you subtract minus x again out of 2. Any question?
So I have not understood that part.
Teacher,
Factor.
I thought we're supposed to use 2 sine then
cos. Why are we starting with cos? Yet it's up. We are adding the same, like.
We are subtracting. What are you adding?
No, we are subtracting the signs.
You begin the cos, right? When you're subtracting, you begin with cos.
Yeah.
Right? Is it okay?
Yes, teacher, it's fine. I have
No,
seen.
it's not. I haven't understood.
You girls, you know factor formula.
Teacher, why do we add x again and subtract it again?
Factor formula. This is now your A, this is your B. We first add, then we subtract. This is the all A.
I'm saying inside the bracket.
And this is your A now. This is the A, this is the B. You first add the A, you add the B.
Okay, teacher, thank you.
And this is the A again, you can subtract, right? Okay. Now, we have changing in Y.
Excuse me, teacher.
Yes.
Teacher, why didn't you put brackets for the second sign? Here, when you had sign x plus changing x, why didn't we put brackets?
Why didn't we? Why do we have?
No, like why didn't we say like inside when we say brackets then x plus changing x?
Here.
Because this negative is going to affect. No, for the second one.
It won't affect this one here. You want me to put this back here?
Yes, why didn't we put brackets? Yes.
That's in a way the negative. It's okay, but that's in the affect. It's independent. So will go. Okay, now you have a 2. By now, never make this error of these 2 can't cancel this 2. Here we have the angle. Here the 2 is independent. Never cross out this 2 and this 2. Have you heard? They don't go. This is the angle, is an independent 2. They don't cross out. Now we have a 2. Then cos of here x and x, you are getting 2x plus changing x. Divide by 2. Then sign of changing x out of to the x will go. That's what we are having. Now, here we can come and say, you can say, now you can, after you come, we divide by changing x. Or you can have this part here, you can say 2, changing y equals to 2 cos of x plus changing x out of 2. Then sign of changing x out of 2. This part here. Here divided by this 2 here, and again by 2. Remember differentiating your aim at getting the y dx.
Teacher, pardon, could you please repeat how you got that step? Then you've written, just written.
Just dividing this 2 here down. It's divided by the trace and the changing x. Now 2x over 2 get x. The change over 2 will remain. There's a 2 here, which has gone, right? But the 2 is divided this change and the 2x.
Oh, okay. Thank you, teacher.
Okay. Now we aim at differentiating, we aim at getting the y dx, right? That's differentiating. So once you reach this step here, you come and divide by changing x. Divide it on your left, again on your right. So therefore, you shall have changing y. Divide by changing what? Divide by changing, divide the changing x on your left. Again, come and divide it on your right. We have a 2 cos of x plus changing x out of 2. I know changing x out of 2. Now divide by changing x It's better you divide the change in x over where I have a sign function. It's much better. If I down this product here, this is a product, right? You can put it anywhere. But it's much better you divide under where it's sign function. So divide this side and this side. Okay?
Teacher, pardon.
I've told you once after simplifying, remember we are aiming at getting the divide the x, right? Therefore, we come and divide by changing the x on your right here, even divide this side. Or, so what we do is much better you divide the changes of where I have the sign function. But if this is hard for you, can do this. You are dividing by changing the x. You can just multiply this side by here. The body is too small. Times 1 over changing x out is here. You divide by changing x, then you divide by changing x. I have it here, right?
Okay.
Teacher, what's that? X out of dx?
I multiply times 1 over changing x. After we divide by changing x on your left hand side and right hand side. I've made it here under changing y. Even here I've multiplied it here. Here this means I'm dividing by changing x, okay? You see it here?
Yes, teacher.
Now
Yes, teacher.
Now after you come and make the assumptions. You say that as changing x here. It's very important. As changing x tends to still put a comma there. Okay. I told you the cos of this x plus the angle. The second part I gave you. Here you get cos of x. This one will go to 0, right? This all quantity.
Yes.
And the sign of changing x over 2. Here you get the same angle. I gave the first part I gave you. Here you get the same angle. And here, whenever I have the comma, here you put the change in y over change in x becomes dy dx. There, after doing all this, you come back and substitute in. This one has become dy dx, okay? You come back here. You have dy dx now.
Yeah. Teacher, question. The change in x has become 0. Then why are you making this become dy dx, yet the change in x has become 0? If we replace it with 0.
Now, no, this can't be 0. This it's just tending. Okay? It's not becoming, but it's tending to 0. What happens? This one becomes dy dx. Then change the y to be that. Now, when you had this curve, why you drew it, I don't know. When you draw, you come and draw your gradient here.
Teacher, we can't see up there.
Huh? Hey,
We can't see up.
Okay, now I will just read it when I remove this part. Now this is what we do. As the change is tending to 0, right? The changes to the gradient becomes the actual gradient. It's just the increment in y over increment in x. Okay? As tending to, as the gradient becomes a line, this change in y becomes the actual gradient dy dx. But for this one here, I gave it assumptions for this last part. The part 2. This one for it will be 0. Okay, you get this angle here. And the sign here, you get the same angle. The change x out of 2. The first part I gave you.
Excuse me, teacher.
Yes? Now, You come back and substitute back here.
Teacher,
Yes.
why do we get the same angle there and sine changing x over 2?
I gave the the first part, the introduction part. I gave you if theta is in radians, right? Do you have that part? Before we went to the EG.
But yes, you gave us cos theta tends to 1.
And the sine, what does it tend to? The same angle, right?
Yes, teacher.
Don't you have it?
We have it.
You have it, right? Even we did the EG number. I told you side of the small angle to get the same angle. So what I'm doing right now here. For the sine, you get the same angle. Don't you have it? The first part I gave you. Where you have theta?
Yes, teacher, we have.
If you are now using that one, if the cos becomes 1, now help explain again that upper part, how it becomes cos x.
I gave the second part when you are adding, go to the second part where I gave other limits. Do you have it? Check the second part where I wrote other limits. Do you have it?
It's now clear. Thank you. It's now clear. I've got it.
Good. Now, when you're adding, remember this is a very small angle, right? It won't make any difference. Are you following? This part here, this is to 0. Now you come back here. This now will be 2 cos of what? X. This part has back here. Then here we go this function. Changing x over 2.
Excuse me, teacher.
Multiply by 1 over 6, yes?
Teacher, it means that when you're finding that part of cos you're using the part for other 0. Then the one, teacher, I'm saying when this upper part here for cos into changing x out of 2, you're using the part for theta in radians, that part, and then the other one you're using other limits, so that you're using 2 different.
Yeah, this one I'm using for other limits here. Yeah, I'm using for the first part.
So teacher, is that how all the numbers will be, or for some cases we'd have to use the same thing?
All the numbers will be like this. Nothing will change.
Okay.
The 2 cases which I gave you for the names. Now you come back, substitute back here. You have a 2 here. This one has become cos x. Here becomes the angle here. Later it was 1 over changing x, which is here. Now this changing x will cancel. This one will go with that one. Even the 2 will go. Even these 2 will go, and you end up getting. Are you first like that? Then I'll give you the final solution. If you have a question, you can ask us. Well,
Teacher, me, you said that 2 doesn't cancel out. Where it's going same?
Pardon?
You said that 2 at first doesn't cancel out.
Now this 2, the 2 with there's no trig function. It's independent. Now this is value. There's no any trig function on this one here. But here there was a trig function cos, right? I follow the difference. Here there's a trig function. It's now the angle and the cos, right? This is independent now. It has no trig function. That's why this one can go and the 2 can cancel. Remember, this one came from this part here for a sine. I follow it. Now this is a value. It's not a trig ratio, okay?
Okay.
That's where they can go. But before, okay, you write that.
Teacher?
What? Yes.
So I'm still confused on that very last part after us saying dy dx. Do you mind repeating that last statement we did?
Which one? Here.
That very last, yes.
Now, remember, we are substituting the back in this. Remember, we said the change in y becomes dy dx. Right? This part now becomes dy dx. This part becomes dy dx, okay? What are written here?
Yes.
Then the 2, we have the 2. This one now has become cos of x. Are you following? And this side change,
yes.
Here, this has become the angle, change x out of 2.
Okay.
You're just replacing back here, that statement there. Then you multiply by 1 by changing x.
So where does the sign go?
Here, the first part I gave you, check the notes which I gave you. The first part, the limit. The first case which I gave you, if theta is in radians, what happens here? Here, this here, it becomes the angle. Where I gave you the EG.
A teacher, on the sentence where we got cos x, I've understood why you said we go to the second, and then we shall get like the value cos x plus the dx is equal to cos x. Teacher, where does the 2 go?
Which 2 here? Which 2? This 2? This one?
No, up. Yes, the 2.
This now is 0 over 2 should be a 0, right? You only get this quantity. It's becoming 0. Okay? Which is this 0 over 2, which will be what? When we get that.
Teacher, on the last part, why do we multiply by 1 out of change of x?
Here we had it from this part. You have it this. Here we divided by changing x here. This you divided by this dividing. You have to maintain it. You cannot multiply it here. Plus which I divide by changing x, divide by changing x, which I multiplied. That's why it's a fraction. 1 out of that. Have you seen it?
Yes, teacher.
Okay. So finally, this I will conclude.
Teacher. So is there another way of calculating a number, like if not using first principles?
The question says first principles, this is the only way you have.
And it's like if they don't specify, is there another method, or this is just how it is always?
Always. That's what you apply. Always. And if the number will be in your paper. But no, it's just a first beginning. That's why you are getting a bit confused. But once you do the second question, you will okay, don't mind, don't worry. You're not understand it very well. You shouldn't worry about this. What's confusing you is here. This one is confusing. Now you look. Let's conclude. Meaning dy dx becomes. We give you 2 cos of x. The 2 has gone. Just give you 2. Then give cos of x. Then this 2 goes. You have a clear custom. This is what you get. So finally, this I work on the question and I just come and conclude that therefore ddx This is how we conclude that dx sine of x get cos. I'll work out the question. When this question sign, you get cos. That's in your head.
There, you say okay, from up there, you say you cancel because it's
Now this independence wrong at angle. I replace this one with this here. This part here. It's normally angle. Yes, sir.
Teacher,
Yeah. What's your question?
teacher, in the conclusion, that whatever written in brackets, it's not clear. What's that?
Sine.
Sine x.
Good. Sine of the angle. That's what I've written. The brackets. So now let's go to question 2. Now let me even work out question 2 for you. But before you go to question 2, people have just joined. That's what I've just joined. This is what I did. I said, this is what I wrote before. And I just doing it. Yeah, I said as changing x, if this angle as change x tends to 0, I know this angle, you get the same angle. You have tan at the same angle, you get the same angle. But for changing x, this becomes a 1. Yeah, this angle, the change in x is measured in radians. And again, this is the first case which I gave you, case 1. Again, I told you, case 2, if you have sine of the angle, what is this now? If you have the sine of the angle, then it's maybe plus x. Here you get sine of x. And you add, but this is changing to 0 now. If you have cos of x, add changing x, then you get cos x. And if you have tan of x, add changing x, then you get tan of x. Basically, this is what we have, it's what we are applying. The case 1, you have the case 2 here. Yeah, sine of the angle, you get the same angle. Even the tan, you get the same angle, but for the cosine, you get 1. Okay? But for case 2, again, here, change x is turning to 0. This will be 0, now you get sine of x. This will be 0 because of x and the tangent, like that. That's what we apply. Now, question 2. Was differentiate what? What was part B? Cos of x, right? Now you let your y again to the set function. You get y plus change in y, add increment because add change in x. Now change in y, make the subject will be minus your y, which is cos of x. That's your y. Now you come and apply factor from which be change in y. It's be now negative 2. I first added 2. Divide by 2. Then again sign it, subtract. Minus x. Which is the change in y equivalent to -2. Sign off when you add your get to x plus change in x divide by 2. Then sign off plus the 2 here of change in x. This has gone. Now, from here, you can divide by change in x. Change in y over change in x will give you -2. Sin x plus change in x out of 2. And change in x out of 2. Then we are multiplying by 1 over change in x. We are dividing by divide by change in x, divide by change in x. Now, from that side, we make the assumptions.
Excuse me, teacher.
Yes.
Teacher, why do we put a negative on that too? Like, why is it -2 sign, yet we didn't put a negative on the other 2 in the other number, yet we were also subtracting?
The factor formula for subtracting cos. That's how it.
Yeah.
Teacher, could you please repeat why we don't cancel the 2 cos? Like, why don't we cancel the 2 cos?
Okay, I have 2 questions. The first question, someone asked why we have a negative. Now, when you're subtracting 2 cosines from factor formula here, it's a negative, okay? When you're subtracting, there are factor formulas. When you're subtracting here, it should be negative. I don't know what asking the first question. The second question, I said why here the 2 is on the trig function. I follow it. I know it's the angle. Okay? These 2 can't cancel these 2. But when you make the assumptions and the trig function goes, then the 2 can go. But here they don't cancel. Because now this is an angle. You can't have 2 sin of 30 divided by 2. And you cancel this. This would be very wrong. Okay? Yeah,
okay, teacher.
This is an angle, but this is but when this angle goes, it means the 2 can now they can cancel, they can divide. Now, so let's make say as changing y, changing x change what to 0. Yeah, the change in y by changing x, we tend to divide the x like that. The sign of x, add changing x over 2. This will tend to sign of x. The sign of changing x over 2, we tend to change x divided by 2. Therefore, this will be divided x equivalent to -2 sin of x. You multiply by changing x over 2. 3 times again 1 over changing x. Like that.
Excuse me, teacher.
Yes.
I thought that every sign we just maintain that same angle. Now I'm so bothered why we put sin x on the first one.
Understand it to 0, this whole quantity. You guys don't cramp. Here we have 2 functions which we are adding x plus in. This is changing now to 0, this whole quantity. You have just seen in the case 2. The 2 are different. Here we are adding this independent. Yeah. This thing to say this whole quantity here now, you get this kind of x. But here you get the same angle. Why is it confusing me now? Here they change it's getting to 0, right? This whole quantity will go. It's what will remain. But here you get the same angle here, the case one which I gave you. We have case one and case two. Now here the two can cancel because this has no trig function now. The two can go, then the change can go. And we make the negative sign of x. Meaning this should simplify because you get negative sign of x is what you get. Okay. You can write that.
Daddy.
Calling your dad. Calling him for rescue. How many is 100 what?
Yeah. Teacher.
Yeah, what's the question?
On the previous number, like part A,
Man.
after us replacing the cos x plus changing x out of 2 and sin changing x out of 2. I remember like the part where we wrote dy dx is equal to, we included the sign on that thing of change of x out of 2. I remember like we included the sign. Yet here on this part, we have not included the sign. We have just said changing x out of 2.
I didn't include it. Sorry. I don't have it. I didn't include it. After making the assumption, I didn't include it. Equal to this what I didn't include any sign. This what I wrote. This what I wrote at that part. I didn't include it. Remember that when they become this part here, why would I include it now? We are replacing this whole part here in this part here. It's becoming dy dx. Here the change is turning to 0. You get x. This is coming this very angle. It's what we have in there. I didn't include it. Heavens. Any question? Let me ask people now. Edwin.
Yes, teacher.
Do you have any question, Edwin?
No.
Has been.
Hey, you got that. Okay, what's your name? Let me mention your name. Maybe you are. Matov Viman. I want to make some the remaining. I want to roll people. Let me check.
Teacher, first do for us the third one, tan x.
Third one.
Yes,
Yeah.
because tan. Yes.
We are going to do it. We are going to work it out. I want to first check here people who are not. Yeah. Do you have any question?
Teacher, no question.
I have a question.
What's your question?
On that part of dy out divided by dx is equal to brackets negative 2 sine x plus dx divided by 2 sine dx divided by 2 brackets 1 multiplied by 1 out of dx. So would it be possible if we just divided by dx straight away, or it wouldn't?
Yeah, it's okay, no problem. It's very, very fine.
Okay.
It's very okay.
So it's a must to conclude.
You have to conclude that when differentiated cost, the negative sign.
Okay.
Teacher, question.
Okay, the last part, differentiating tan. Let's work out that question. This is what we are going to do. For a tan, this is what we are going to do. Okay, that's that last part and this last board. Our part is the tan of x. Let your y be tan. This is what you do. Now get y plus change in y. Equivalent to tan of x, add the increment in x. Change in y becomes tan x minus your y, which is tan x. Now for tan here, what to do? We are going to convert it. We change the tan in terms of sine and cos. Have you heard? We change the tan in terms of sine and cos. Meaning our change in y becomes sine of x plus change in x divided by the cos minus sine x, like that. Now come and get the LCM. Change in y becomes sine of x plus change in x cos of x minus of x cos of x plus change in x divided by cos x plus change in x. I'll go to LCM, which you can see. Now from here, you recall that
teacher,
A plus B compound angles. What do you get here? Do you have compound angles? Eh?
Yes, teacher.
Yes, teacher.
Okay, what do we get here? By what? What do we get here?
Sine A cos B.
Okay. Okay. Now this is what you get, okay? Meaning, look at my numerator here. Look at this numerator here, and look at that expansion. How are they related? Meaning there, my A is x plus change in x. Are you following? and my b is the x. Mean this one now becomes the y, changing the y, equivalent to sine of x plus changing the x.
Take 1, 2, 1, 2. Okay, that's better.
Minus x. Let me call it a negative here. Be negative. Divide by cost of change. Can you see that? Up, look at the numerator. When you expand this whole quantity, this is what you get. Look at the numerator. When you expand that, this now this is your A. This is like your A. This is like your B. When you expand the numerator, this is what you get. Are you following? Look at that part. Okay?
So we are looking.
You are looking. But when you expand this one, this is what you get. Meaning the change in y becomes, instead of changing x, here this will go, divide by that's what we are having. Look, if you have any question, ask before we conclude.
Teacher, I beg your pardon on the last part.
Where does the
Teacher, I've not understood the expansion thing.
Teacher, on the last part.
The third last part.
From the change y.
Third last.
And yeah,
From the change.
Yeah, the x go here, go is x.
At the last part.
Change y.
on the other side changing y?
This side we changing y. Yeah, there, changing y. But down this side. This side.
Before recall.
Yeah, there, yes.
Yeah, you go there.
Teacher,
Yes.
teacher, please explain the part after recall.
Okay, now I've told you when you expand this compound angle, expand this part here, okay? This is what you get if you remember that part. Now, if you compare this part here and this part here, my numerator, this question. It's an expansion, now this becomes your, it's like your A, you have your B. When you expand this after in factor form, this is what you get. When you expand this one,
Okay, thank you, teacher.
Why don't we apply compound formula on the denominator?
here you can't apply. This is a product. How do you want to apply it here? Here we're not expanding. Here we are, this one, where does this one come from? When you expand this part, here you're going to simplify your numerator. When you expand this numerator here, this is what you get. Meaning this one comes from this one. Another simplify the x will go, and this is what remain with. Okay? Now you, come and divide by changing x. Now you have change in y. divided by change in x equivalent to sign of change in x out of cos of x plus change in x cos of x multiplied by 1 over change in x. Now you come and make the assumptions. I shall say as change in y, change in x tends to 0, our change in y, our change in x becomes dy by x the sign of change in x, you get the same angle, and then cos of x, you get cos of x. Therefore, the dy now this becomes dy dx given by up we have change in x, what remains divided by cos of x times cos of x. Whatever the 1 over change in x. Which will be dy dx given by 1 over cos squared, which will be squared x. Therefore, if we shade x tan, you get x squared x. Yeah, that's what you get. If you have a question, you can ask. But
Teacher, can you explain where the x goes?
Pardon?
Where the x goes on the after recall, that part.
After recall, this is your A now. This part here counts for the top. Even I already moved it. God will you factor for your compound angles. If you do not need to.
The x cancels.
Which one?
Mariam, it's x minus x, which gives you 0. So you remain with that change in x.
Yeah, that's what.
Yeah, thank you.
Thank you.
Now just go through this work you have done today. You can repeat all the numbers we have done, repeat all the numbers we've done. And then when we meet, when I meet again? On Friday.
Next time.
When we meet on Friday, we shall do the remaining 3 questions.
People, how are you?
Happy Eid.
Mr. Sendaula. Mr. Sendaula, go away.
No. Get out of here.
I'm so humbled.
Get out of here.
Teacher, give us
please
data abusing our laptops.
Laptops.